Section 1.4 Collecting Sample Data. If sample data are not collected in an appropriate way, the data may be so completely useless that no amount of statistical torturing can salvage them. Recall the example we went over in which the Literary Digest predicted Alf Landon to win the 1936 presidency. Given the way that sample data was collected, there was no way to correct for such poor polling techniques. We usually obtain data in one of two ways: observational study or experiments. With an observational study, we simply observe and take measurements of subjects, whereas with an experiment, we apply some treatment, such as giving subjects some medication, and observe the effects. In either case, whether we are conducting an observational study or an experiment, it is crucial that we are collecting the data from a good sample. We'll go over a few methods we generally use for sampling, each with a varying degree of goodness. To find our samples, we can use a voluntary response method, a simple random sample, a random sample, or a probability sample. We have other methods too, which we'll talk about in a minute. With a voluntary response sample, the subjects decide whether or not they want to participate. Since subjects generally choose to participate only if they feel strongly about the issue, that emotional component taints the results. Consider when you call PG&E and they ask you if you'd like to stay on the line for a brief survey. The only time I have stayed on the line is if I have had bad service. Another example would be that Literary Digest poll. They sent out 10 million ballots and only a little over 2 million decided to respond. If you recall, that poll did not accurately predict the winner. A simple random sample is generally considered the ideal way to find a good sample. Using this method, if we need, say, 12 subjects, one group of 12 subjects has the same chance as another group of 12 subjects. A random sample is similar, except each individual has an equal chance of being chosen. We'll explore this difference a bit more on the next slide. A probability sample is similar to a random sample, except each subject may have a different chance of being chosen. For example, if I have a room of 50 men and 50 women, and for my sample I need 49 women and 1 man, the men each have a 1 in 50 chance of being chosen, and the women have a 49 in 50 chance of being selected. This touches on the concept of probability, which we'll explore in more depth when we get to Chapter 4. A simple random sample versus a random sample. Consider the U.S. Senate. The U.S. Senate has 2 representatives from each of the 50 states, thus having 100 members. Suppose we need to select 2 members for a committee. If we choose randomly, then any group of size 2 has the same chance of being chosen. If instead we randomly choose a state and then select both representatives from that state for our committee, then each of the members of the Senate has a 1 in 50 chance of being selected. So it is a random sample. It is not a simple random sample because not every group of 2 has the same chance of being chosen. For example, the group consisting of Barbara Boxer and Dianne Feinstein, California's representatives, have a 1 in 50 chance of being chosen because they're both from the same state. But a group consisting of Barbara Boxer and Thad Cochran of Mississippi have a 0 chance of being selected because they are from different states. So this is not a simple random sample, but it is a random sample. We have other means of generating a sample, and some of these work well in certain situations. We have systematic sampling, convenience sampling, stratified sampling, and cluster sampling. With systematic sampling, subjects are lined up. We select a first one, and then we select every kth sample after that. Think about a chocolate factory with a conveyor belt. We might taste the first chocolate, and then taste every 100th chocolate after that to make sure the chocolate is coming out of the factory and is up to standards. With convenience sampling, we use the results that are easiest to get. For example, if I wanted to know the average height of students at Sierra College, I could generate a simple random sample, but it would be easier just to ask everyone who has taken this course, what is your height? That would be most convenient. With stratified sampling, we separate the population into subgroups based on some common characteristic. Then, from each of those subgroups, we randomly choose certain people for our sample. Cluster sampling is similar to stratified sampling, except instead of drawing a sample from each subgroup, we pick a few subgroups and choose each member in that subgroup for our sample. When considering observational studies, we have three main types: cross-sectional, retrospective, and prospective. Cross-sectional studies collect data observed from one point in time. For example, observing subjects as they are right now. Retrospective studies include data from past events. This is also known as case control studies. Prospective studies collect data from groups at future points in time. For example, you can collect data right now and then collect data at future points and compare the results. When designing experiments, there are several things to consider. In general, we have a treatment group and a control group. Subjects are put into one group or another by a process of randomization. Randomization is important. Suppose we are testing an anti-smoking drug. If we instead decide to put women in the treatment group and men in the control group, what happens if this drug only has an effect on men? We will never know, since women were the only ones to get the actual drug. The results of the experiment will say the drug does not work, even though it may work on men. We also must make sure that we design our experiments in such a way that it is replicable. When results are published, many times other groups want to verify the results by replicating the study. This is typical of any scientific experiment. Another way to consider replication is to realize that any experiment must be done on more than one person. When you read about studies, you often hear about double-blind studies. Blind studies are when the subject doesn't know whether or not they are in the treatment group or the control group. This is almost always the case. The researcher, however, may inadvertently reveal some information to the subject. So we must also consider a double-blind study where not only does the subject not know if they're in the treatment group, but the researcher doesn't know if the subject is in the treatment group either.